All right, so look up, please. So here was a question. They said, evaluate the limit of x cubed minus 1 all over x squared minus 1 as x approaches 1. Now, to solve this, listen up, please. Listen up, please. To solve this, your solution to this is dependent on first things first. I've said, if you're fast in writing, your first task would be using direct substitution. So if I use using direct, please, subs in full is substitution. So put x as equal to 1 here, of course, because as x approaches 1. Put x as equal to 1 here. That gives you 1 cubed, that's x cubed, minus 1 all over x squared. 1 squared minus 1. That's equal to 1 cubed is 1 minus 1 all over 1 squared is 1 minus 1. If I do this, this gives you what there? 0 minus, 0 all over, this is equal to what there? Undefined. All right, that's the first task there. Now, in solving this from the actual sense, if I look at this, this is a difference of 2 square question as well as a difference of what there? 2 cube. I know that x cubed minus 1, this is the same thing as saying x cubed minus what there? 1 cube. They're the same thing. Because 1 cube gives you what there? 1. So this and this are the same thing. It's called difference of 2 cube. Now, what's the difference of 2 cube? If I have a cube minus b cube, what will this give me? If I expand this, what do you have there? This gives you a minus b into a squared. Hold on now. Hold on. This is difference of 2 cube, not difference of 2 square. This gives you plus what there? AB plus b squared. This is the difference of 2 cube. So if I have 2 terms subtracting and they are being cubed, what you have there is a minus b, the first minus second, multiplying the first squared plus the product of the first and second, that's ab, then plus b squared. If I multiply these two, I'll have this. So you need this thing here, this concept. Please take note. In essence, if I say x cubed minus 1 cube will be equal to, of course, in this case here, a is x. So if I have a, that becomes what there? X minus b. What's b here? 1. So this into 1 into a squared. What's a here? X. So it becomes what there? X squared plus ab. AB is a times b. That's this times this. 3x times 1 gives you what there? So plus x plus, next up, or should I write in full? Some person go and revise and be like, why did you keep the 1? I thought you said it's AB. Why am I saying only x? What happened to the b? Let me write it out. Plus, finally, b squared. What's b there? So that becomes what there? 1 squared. This should actually be in its round bracket. Simplifying this is equal to, what do you have here? X minus 1. This into, this gives you x squared. This gives you x squared plus x times 1, x plus 1 squared is what there? 1. So look up, please. Look up. Look up. What this means is that the value of x cubed minus 1 is the same thing as me writing it as x minus 1. This into x squared plus x plus 1. That's what I'm saying here. All right. So to solve this one here, you need an idea of difference of 2 cubes. That's this. I've showed you how I got that. Okay. 1 is the same thing as what there? 1 cube. So I have this. With this, I am done with numerator. Let's go to denominator. In denominator, I have what there? X squared minus 1. So I have x squared minus 1. This becomes what there? A difference of what? 2 squared. X squared minus 1 is same as what there? X squared minus 1 squared. Because 1 squared gives you 1. It's called a difference of 2 squares, please. It's called a difference of 2 squared, please. Right. For difference of 2 squared, if I have a squared minus b squared, what do I get there? A minus b into what there? A plus b. Please, all of these things here are things you should have done before now. They are quite old mathematical concepts. Quite old. All right. In essence, if I have x minus x squared minus 1 squared, what do you have here? A. What's a here? X minus, what's b here? 1 into what there? X plus 1. All right. So in essence, x squared plus x squared minus 1 is equal to this. If I substitute, look up please. If I substituting, I have that this one here, I have that x cubed minus 1 all over x squared minus 1 is equal to this one here. We said it was a difference of 2 cubed, and from that stuff that we got this answer. We said the value is equal to x minus 1 into x squared plus x plus 1. We had this. That's for numerator. All over for denominator, we said this was a difference of 2 squares, and that is x minus 1 into what there? X plus 1. Looking at this, I can see that I have x minus 1, x minus 1. Both of these terms here can cancel out. That means from here, this will cancel this. So what do I have there? X squared plus x plus 1 all over x plus 1. So I have this. So you have this term here. At this point, you now substitute. Please, as x approaches what there? 1. So put x at 1. At this point, you now say substitute x as equal to 1. Put x as 1 here. What do you have here? 1 squared plus 1 plus 1. That becomes x squared, that's 1 squared plus x, 1 plus an actual 1 there. All over, what do you have there? X plus 1. What's x there? 1 plus 1. This is equal to x squared is 1 plus 1, 2 plus 1, 3. 3 all over 1 plus 1. Your answer is 3 over 2. So this was from last year. You have this as 3 all over 2. If you have x to the power 3 minus, so listen. In some cases, you could have this as x, in some cases, you could have this as x cubed minus 27 all over x squared minus 9. Again, in this point, it has to do with how well you can break this down. This is same as x cubed minus 27 is what there? 3 cubed. 3 to the power 3. That's 3 cubed 27 all over x squared minus 9 is what there? 3 squared. From here, follow this. So in this point, what you have here is x minus 3 into x squared plus x times 3 plus 3 squared. Just leave that pattern there, that's it. So this was Davis's past question last year, right? Does it say the same kind of questions? I think so. When I was here, when I was following up, I think it said the same thing, the same pattern. So that was the discussion last year. Let's look at another question he gave on limit, and then we can proceed. Please look up. For 5 marks last year, they gave you this one here. This was in college. For 5 marks last year, they gave you this. This in engineering, also learn no. How do you solve this one here? Again, the first thing you want to observe is that I have what there is square root. And when you have a square root, what do? Rationalize. And when it comes to rationalize, what's the first you do there? Get the conjugate. What does it mean to get conjugate? It means that term that has square root, there's a sign between that term and another term. So what do you do here? Change the sign to what there? Positive. So you now say conjugate, the conjugate of root x plus 4 minus 2 is equal to what there? Root x plus 4 plus 2. So you have this. We've said for conjugate, just change the sign in between them to the opposite. If it's minus, it becomes plus. If it's plus, it becomes minus. That's it. All right. When you're done with this, what next? You will multiply both numerator and what there? Denominator by what there? The conjugate. So take numerator. This is equal to, numerator is x. Multiply this by the conjugate here. That's root x plus 4 plus 2. This all over, multiply denominator, this one here, root x plus 4 minus 2. This multiplies each conjugate, root x plus 4 plus 2. You have this. So multiply numerator and denominator by conjugate. This one times conjugate, this one times conjugate. That's all. Let's simplify this. This is equal to, from our first example, you know that this man here, don't expand yet. It might cancel out. So I'll keep this as x into root x plus 4 plus 2. This all over. In expanding this, what do you have? The first thing you want to remember that when it comes to expanding, you take the first term here, multiply everything here. That's how you expand terms in brackets. Of course. Take the first term here, multiply everything here. That becomes, first term here is root x plus 4. Multiply everything here. What do you have there? X plus 4 in square root plus 2. I took the first term here. I multiplied everything here. Second term here is what? Use minus 2. Multiply everything here. Root x plus 4 plus 2. All right, so you have this. Use first term, multiply everything here. Use second term minus 2, multiply everything here. So what do we have here? From this will be equal to, again, do not expand this one as we did previously. Don't expand it, just leave it there. That's x into root x plus 4 plus 2. This all over. For this one here, what do I have there? This times this, what do I have there? Of course, x plus 4 root x plus 4 multiplying root x plus 4. Whenever you have the same term in square roots multiplying, it becomes that term. So this gives you x plus 4, this, then plus this times 2 gives you what there? That's 2 root x plus 4. Okay. Next up, minus 2 into this. What do you have there? Minus 2 root x plus 4 minus plus minus 2 times 2. So you have this. Let's simplify this. This is equal to x into root x plus 4 plus 2 all over for this. What do I have here? X plus 4. Okay. Next up, this will cancel this, Abby. Same thing. This cancel this. What do you have here? Minus 4. This will be equal to, here I have x into root x plus 4 plus 2 all over from here. 4 minus 4 cancels out. What do you have there? X. From here, these 2x can cancel out. If I cancel x, x here 1, x here 1. So what do you have there? Root x plus 4 plus 2 all over 1. Okay, this x cancels this x here, so it's 1. Anything all over 1 gives you what there? That same thing. So I'm having this as root x plus 4 plus 2. At this point, I am done simplifying. What do you do here? Put x as equal to, what limit were you given here? Put x as 0. If I put x as 0, this is equal to root x plus 4 becomes what there? 0 plus 4 plus 2. And that's equal to root 0 plus 4, 4 plus 2. And that's equal to root 4 is what there? 2 plus 2. And that gives you what? 4. So the answer there is 4. So that's it. Don't forget, whenever you see a square root sign, what do? Rationalize. That's what you do. I'm coming. So that's your 5 marks, literally.